Hello, internets.
Hello, Internet.
Hi.
We got Satch and Rickles on the stream.
That's me. And Rickles.
There's Rickles up there dancing.
It's called acoustic dancing
Acoustic dancing.
Why
Okay.
is it acoustic?
because there's no music.
There's no music.
Yeah.
That doesn't matter.
That's so
Silence
funny.
dancing.
What about neck whining?
Neck
What do you call
whining.
Neck whining. Chest whining.
Yeah, that's neck one.
Right, Don?
I don't know.
Are we embarrassing your stream?
No, not at all. I'm just not paying any attention to you. This is the difference.
Whatever, man.
I'm scrolling back through our channel to see what the questions were from last week, so that I'm ready to start the stream for
Are
the
we
folks.
streaming it?
Yeah, we are. We're live.
Okay. There you okay.
Okay, I found it. I found what we're gonna do. Okay. Got the problems.
Send me the links to. Well, I could just go to your YouTube actually. Actually.
It's in the Discord. Link to the it's in the Discord. Yeah.
Oh, good.
And I'm just going to drop our live streaming link for VS Code. Feel free to
Yes.
Connect up.
We'll be joining.
free to.
I'm sorry. Oh.
Oh, it
I'm
took
okay.
me. Okay, I got the copy.
I have to stop this b-ball situation, okay?
Yeah, go ahead. Go ahead.
B-ball situation.
B-ball. Yeah, that's like all we do now. Right,
Oh.
Rich? Oh no! That's like all we do now. Okay, all fixed.
Rookie mistake, Satch.
It was muted on my computer, but when I connected this to stream it, then it turned back on.
All right. So should we go? Are we starting?
Let's do it.
Okay. So we were solving problems last time. Let's start Quokka. Did you folks get Quokka working?
No.
You
yeah,
did.
we can't seem to get it to work.
Oh, even locally on your own machine.
Oh, it works locally.
Okay, then that's fine.
Do you have it working locally?
I don't know. No, I don't. But I thought that it just works locally.
I was like, wait, I can't get it to work. How did you get it to work?
Okay, I'm gonna try working it now. Quokka.
Copy message.
Okay, so let me get this. I'm gonna get a new file. Or let's see here. We had our main. We have this file called left hand.
I don't know what this is about. Should I just click disable? Why is there a disable button?
For Quokka?
Mm-hmm.
I don't know. I don't even have an enable button. I can't see it. Click to open start view. And then it just takes me to like the Quokka homepage.
How do you get it running usually, Don?
How do I get it running usually? So if you're watching the stream right now, you just do Command-Shift-P, and then you say Quokka start on current file. And then if you do that, it runs. But we don't need to do that. I'm not sure I'm a big fan of this Quokka thing anyway. Did it work for you?
Yeah, it worked.
It worked? That's all you have to do. So that's all you needed?
You don't know. Yeah, okay, don't judge me.
I'm not judging you. I'm not judging you. But
you.
I mean, I do tell you folks to message me if you don't know how to do something during the
That's
week, and I
true.
get no messages from you, and then we start our stream and you still don't know how to do the things. So that's where the judgment actually comes from, if I am judging.
Oh, okay. I
Ask me
understand.
questions.
I'll ask you questions now.
Okay.
There's no judgment.
All right. No more judgment. All right. Should we start?
Yeah.
Okay, so the problems that we worked on last time were, what were they? Let's see. This. Translate a sentence to Pig Latin. Check if a word is a palindrome. And check if two words are anagrams of one another.
Yes.
All right, which ones did you achieve?
Anagram.
You did? You got anagram?
Yeah, but I looked it all up and stuff, and I feel like I cheated.
Oh, no, it's not cheating if you understand how it works. So let's go. So you got anagram. What about the other ones?
Yeah, Pig Latin is running.
Okay, so join up and then let's do Pig Latin first.
Okay, copy link. Join.
Nice, Darkmon. You've joined.
Nice.
Mine opens up a link. How do I do this again?
On the left side, should be a live share button. You click that,
Oh, yeah.
copy the link, or make sure you have like link copy first. Am I in the live share right now?
You are?
Am I in now?
Oh, I see. Yeah, you are in the time.
That's so strange.
Oh, Satch is in, yeah. Mm-hmm.
I just click live share, but I don't have to paste any link.
Yeah, you shouldn't. You should just be able to click the link and it will get you here.
Oh, because what it does for me is like it opens up the web browser.
Yeah, me too.
Yep, and then you keep clicking and eventually it'll open, it'll take you back.
Oh.
Are you in? Are you at the file?
Yeah, we're both. I just opened up the Pig Latin file. You see it?
No. Are you in a different VS Code? You have to be in the same VS Code as me, the one that we're live sharing on.
Oh.
You can create a new file. I can create one for you. Let's do piglatin.js. You can put it here. Satch is there. I see her cursor.
Oh. How did I get into there? And now Command-Shift-P.
Yeah, I don't know if it'll work for you.
Oh.
But try.
Focusing didn't work.
Didn't work? Okay. That's fine.
It doesn't even show up when you search files.
Command-Shift-P and then start on current file. Coca, start on current file. Okay, it's fine.
I don't think it will let me open a Pig Latin file if this one's open. So I'm going to close this. Let's try it.
Wait, mine is gone now.
Okay, well, I'll just copy it.
Yeah, you have to copy it. That's the only way. Okay. Let's see.
Wait, mine isn't. Oh, JS tutorial.
All right. Okay, I see your code. I'm going to reformat it. It should actually just happen automatically. All right, let's see what it does. Start on current file. Or better yet, let's maybe just move away from Quokka. We don't need it. But
it gives you the answers.
But you can run it from your command line, and it's better that way anyway. You should understand.
Yeah, we got practice.
Yeah, so node space piglatin.js. iWay, oflay, ethay, unshine say. All right. Let's review the code and see how you did it. Okay. Okay, so for words that start with a vowel, so words that start with a vowel, I see. You basically don't move the vowel, right? You
right,
say,
and we do that way at the end.
okay. For words that start with one or more consonants, that's the else block. Check for multiple consonants. I see. So you're gonna look. you really went. You really got into it, huh? You wanted to ensure, because I told you you didn't have to do it this sophisticated, but that's fine. Okay. So you're gonna look for th so that it becomes ethay, right? The th moves to the end. Okay. I like that you chose a sentence that exercises all the different cases in your function.
Yeah, it was Satch picked that out.
Nice. Well done. So let's see here. Check for multiple consonants. Hey, and you used break. How did you know to do this? I didn't teach you this.
Break. Well, we did a lot of searching and perusing.
Okay.
Yeah.
All right. I understand this code. You explain the code to me because I need to make sure you understand the code. Let's go.
Okay. So I guess from the top here, the idea was to make sure that, well, as the recipe describes. So first of all, we're checking for vowels, and we're looking for the first occurrence of a vowel.
Uh-huh.
And if it's within the first letter, then just do the way. But if anything else happens, essentially, and in the case where it doesn't start with a vowel, like with a consonant, do this loop. If it happens to have multiple consonants at the beginning, we're essentially looking for the first vowel again, in the first instance of it, so that we can remove any of the previous consonants, slice them out, and then kind of move them to the end, so it forms that, and then it would end the loop, right? And then go down to this next part here where we return the string. Nice.
Okay. Now explain the second function here.
Second function is meant to pull the first one, the helper function. So it looks nice and clean. So I think the idea here was, I guess, we run from this function, so we want to make sure everything's lowercase so it doesn't get bugged out. We split the words so that it can do each word individually.
What's this?
And then this thing here, what it does, it removes any of the spacing, because I didn't really know. Like, I think there are multiple ways to do that, but this is what I found, so I just plugged it in and it worked.
Okay.
So it's meant to remove any of this stuff here, like these little spaces.
Yeah.
And then,
let me actually just correct that slightly. So
yeah, sure.
What it's actually going to do is remove instances of two spaces.
Oh.
So when you split on a space, it removes one space. But if there are two spaces, then it will split twice and then give you an empty token in between, which is this. So this ensures that you filter out double spaces. because otherwise you'll try to call your one-word function on empty spaces, and you don't currently have a handler for the case of an empty space.
Right.
Okay. Continue.
And then now we have another variable here, or sorry, another loop here that looks for, what is it doing here? Words. Okay, so it's looking for replacing the word with the new big Latin word in the array. And so once that's done, we put the sentence back together instead of just leaving it as an array, and then we console log it.
Nice. Okay, that is correct. So let's take a look, see at so first of all, this is good, but here's better. Don't do that.
You do that /W thing.
Oh my god.
What's that? What'd you say?
There's this thing that Satch and I saw, and we cannot decipher it. I mean, we've used it for the other code.
The anagram.
We are lost when we use it because we're like,
what the hell is it?
//, what does that even do? W. But it's something to do with removing symbols. So okay, go for it.
And there was an array involved.
Yeah, we'll learn. I think we're going to learn those things today. I left a few interesting topics. It sounds like you might have encountered regex already, but I was going to teach that this stream. So here's the thing. I would say that this is maybe a bug. I don't know. You tell me. So let's convert I love the sunshine, but there's 2 spaces after I.
Right.
If you run your code this way, because of the way that you've structured it, because of the way you've constructed it, you're essentially removing the double space, right? Maybe that's not behavior you intend, because let's say you have a translate function and an untranslate function, right? Ideally, those should be symmetric. If you go one way and then you come back, then the values ought to be, the result should be the same as what you put in, right?
Right. Okay, I see.
There's nothing. I mean, you solve the problem based on the conditions that I told you, but I would write it this way. So if so the reason why you can't remove this filter is if you run this code now, look what happens. Oh, how about that? It just worked.
It adds a space or something like that. It looks like there's like this 2 spaces between.
Oh, I'm surprised that worked. I thought that this would have crashed, but that's okay. So yeah, you just don't need the filter because it works as intended now, right? It kept the 2 spaces.
Oh, like as in like say the format was purposeful, then it wouldn't like reformat it.
Correct. Like let's say that this the extra spaces was intentional in order to, I don't know, for whatever reason. This ensures that it doesn't mess with it. Okay, I like it. Good job.
Good job.
Yeah, good job. Let's move on. Yeah, what's the next one?
It is the anagram.
Okay, did you do that one?
Yeah, but I didn't really understand what I was doing, really.
Yeah, we were kind of like, yes, this works, as we were doing it.
Okay.
But like for example, you mentioned regex, and we don't really know what that means. All I know is that it's like it removes symbols so that it makes it so it doesn't impact the function.
Do I have to copy this into another file?
Yes, I created a new file, anagram.js. Just paste it into that file. Okay. Let's save this file. Let's try it out. Node anagram. True. Okay.
So, okay, what is a character map? Is my question. They use that a lot in this code.
Well, first let's see. I'm looking at this thing right now. Let me see if this is real. Okay.
So this
Uh-huh.
guy wanted to like also include like if there are spaces in the word or if there are exclamation points,
Mm-hmm.
then it would remove those things
Mm-hmm.
from the word. So his original examples for string A and string B were like TH and capital letters too. For the word the and like yeah,
I see. Yes.
you know what I'm saying. So he made it kind of complex.
He made it. Yeah. Yeah. Okay. Uh-huh. Yeah. So this is a regex right here, which we're going to learn today, and I will explain to you what it is. And this is, yeah, it's doing exactly what you said it is. It's eliminating them. So we'll talk about this. This is very cool. I'm glad you encountered it already because you'll be primed now to understand where we're going.
Yeah, because I was trying to like listen to him talk about it, and I still did not know what he was saying,
Okay.
but I was intrigued.
I want to see if that will return false. Let me see. Okay, good.
Mm.
All right. Sounds good. Okay, so this was a way. Assuming now, let's think about the recipe for this. Oh, we have one more function, right?
The palindrome?
Yeah. Did you do that one too?
We started it, but we didn't finish.
Okay.
There's some kinks that are left in it.
Okay. We'll do it. We'll do it later. Let's just talk about anagram first. So, anagram. Fundamentally, what is this? What are you going to try and do here with an anagram?
So I guess you'd have to know the two anagrams, and it's like a fact checker. Is this an anagram or not? Is that what you're asking?
What I'm asking is, let's try and come up with your own recipe for this. So you came up, you found some code that does the trick, but how would you check to see if two words are an anagram? Like imagine you, as a person, had two words next to, like on paper, and you wanted to validate that one is an anagram of the other. How would you do that?
Mm. And that also means that they have the same letters, like 5 letters in this word and 5 letters in that word, right?
Yes.
I guess I would log each word, make a note of each letter
Uh-huh.
in each word, and see if both of those if those two words match up in their letters.
Okay, so be precise about it.
Okay, I would look at word,
Okay.
and then list each letter,
Okay.
and then I would look at the other word
Uh-huh.
and list each letter,
Okay.
and then I would cross-reference those two lists to see if they both match in all of the letters.
How do you do that? That's excellent,
Okay.
by the way, but how do you do that?
How do I match them?
Yes.
Oh, well, I would do it as a person visually
Okay.
by like, see, does this have an A? And then check if the other word has the same letter.
Okay. Totally
I don't
reasonable.
know.
Let's do it. Let's try it, right? Let's
How would a computer do that?
hmm?
We don't look at things. Okay, let's try it.
So let's do it here together. So we have let's do something that is an anagram, and then we'll do something that is not an anagram, okay? So let's do there, and I don't know. I'm not good at knowing what anagrams.
Anagrams?
Okay, so here are two things that are anagrams, yeah?
Yeah.
Let's comment. Okay, so you said you would turn them into a list. So if you did that, then we now have a list of them. Yeah? Then you said you would cross-reference. And when I asked you what that means, you mean you would visually look to see where they match. So here is one way that you might say that might achieve the thing you're saying, right? You say, okay, look at the first letter, T. Then you check to see if there's a T in the other one, right? Okay, so you found it. So then you move on. Then you say H, and then you check, and you see, okay, yeah, I have an H. Then you have E, and you check and you see that you have an E here, right? So you cross-reference. And then R, and you cross-reference, and you see you have an R. And then E, again, you have the first E and the second E. So I have here's the question for you. Is it necessary, is it important that this E match with this E and that this E match with this E? Or does that not matter?
I don't think it matters. But it probably does.
Yes, it matters. You for every instance of one of these, you need to make sure that the same number of them occurs, right?
Yeah.
So here's another way. There's a number of ways that we could do this, right? But here's one way. We can say, okay, start with the first letter, and then remove. So like if we start with this letter, go into the second word and remove it when we see it, right? So if you're doing it on paper, if you're trying to be systematic about it, you look at the first letter in the first word, go through the letters in the second word, and then cross it out, right? Just draw a line through it. Then you go to the second letter and do the same thing. Go through the word and cross out the letter when you see it, right? Then when you see the next letter, go through the word, cross it out when you see it. Then you go to R, cross it out. Then you go to E, cross it out. And if at any point in time you reach the end of the list and you didn't cross something out, then you know it's not an anagram.
There would be a remainder.
You would either reach the end or there would be a remainder.
Or there would be,
You would reach the end and you didn't cross something out. Or you finished the first word and there are still letters left in the second word. Now, let me think. So hold on a sec. You said that you didn't think it mattered if we had to match up the E.
As in, as a human, if you saw the first E on the first list and then crossed out the second E in the second list, there would still be an E left over.
So here's an example of a situation where it's not an anagram, where I think that algorithm fails. You go to this E, and then you match it to this E. You go to this A, you match it to this A. You go to this A, you match it to this A. You go to this A, you match it to this A. These are not anagrams of one another, but your algorithm says that they are. So it is necessary that you have a one-to-one mapping between these two, right? Between every letter. Okay. So there's a number of algorithms here and that are possible. And one thing I want you to notice is that like how many operations you had to do to conclude that two things are an anagram of one another, right? So for these two words, you had to check for this letter, you had to find it in here, then remove it. Then for this letter, you have to find it in here, then remove it. Then for this letter, find it in here, then remove it, and so on, right? Can you think of another way that we could do this?
Instead of searching for them? Another way? I can't think of.
Oh, I have an idea.
Yeah.
Tell me.
What if you were to, because I guess the idea is that you could, as long as the letters are the same, it doesn't matter the order, right?
Mm-hmm.
Maybe you just arrange them alphabetically or something, and then compare them, and then revert them back to whatever you need. Or because I think really no, you just need you just need a true or false, so you don't even need to send the string back.
Well,
what if you just arrange them in a way that you would like, and then that makes sense for you in your code?
Like order each of the letters in alphabetical order.
Yeah, and then you're comparing 1 to 1, 0 to 0, 2 to 2.
Yes.
Is that what you were thinking?
Is that what I was thinking?
Yeah.
That's the gist of it. Yeah. There's another. I was thinking of something slightly different, but that way of thinking about it is exactly the same. It's conceptually exactly the same. So here's another way. You could create a count of every letter. So you could say, you could create some sort of structure that maintains the count of every letter. So you could say that E, there are 2 of them, and H, there are 1 of them, and R, there are 1 of them, and finally T, there is 1 of them. And then you can just check to see that this matches this. What you managed to do, Rickles, was not only come up with the solution, but come up with an encoding for a way to easily do the comparison. So you did 2 steps in one, right? You were like, okay, I will sort this so that it becomes E, H, R, T. And now we have this thing that is comparable between anagrams, because all things that are anagrams will result in the same output, okay? And the word we give to something that behaves like this is a signature, right? The anagram signature for there is EEHRT, right? The anagram for the anagram signature for RETHE is the same thing, EEHRT. And because they're the same thing, we can say that these 2 words are anagrams of one another, right?
What?
Can you still hear me?
Yeah.
Something happened to my audio for a sec, but it seems to be okay. Okay.
Yeah.
All right. So let's do it Rickles' way. So we're gonna do function is anagram, word 1, word 2. And what we need to be able to do is sort the letters in the word and join them back up. So let's quickly see how to do that. Let's do JavaScript string to array. This is what I need to do first. So it looks like we can use split. Let's see if this will work. So we'll just say console.log word1.split. And I actually just want to split on empty so that it turns into an array. And let's see. We'll just call is anagram here with there and RETHE. Let me bring you folks back on the stream. Okay, let's run it. And so yeah, it is working. Yeah, there got printed out as an array. Okay. Now we want to sort it, so we can say dot sort, I believe. Let's try. Yep, and now we have EEHRT. And now we want them to be joined back together to make a single word. So you can say dot join. And I believe that's it. Yeah, so there it is. EEHRT. That's our signature. So we can say function anagram signature for a given word is to do what we just did here. Right? You got me?
How come it? Oh, I see. Word 1 split.
Yep.
And sort. And then what was the join part again?
It puts it back. It turns it from an array back into a word.
Crazy.
I know.
So many things happened in that line there.
I know. Maybe I shouldn't do such things to you. But it's
No.
okay.
That's okay.
So now what we can do is we can do this. We can say,
sorry to interrupt. So for that, in that case, is it just like, does it do it in the order in which you typed it? Like, so it would do split first and sort and then join?
correct.
And only split and join have the quotes. The quotes are an array?
So let's break it down. So let's go down here. I mean, you're asking great questions, and you totally should get a proper answer. So let's make some variables. Let word equal there, yeah. So now we can say word dot split, and if we pass it, so split is something that will take a string and break it into pieces, and you pass it what you want to break on. So remember when you did Pig Latin and you were separating the sentence into words, you split on space so that you get back an array of words, right? In our case, we want to split on everything because we want just a letter in every entry in the array. And there's a little trick to that. You just say split on this empty string, and the empty string matches every character boundary, and so it will split on all of them. Does that make sense? It's kind of a little weird. Now the result of splitting is the letters. So we say let letters equal this split. And so if we look at letters, we now see that we have an array here, right?
Yeah.
So now I can say, if I wanted to join them back together, I can use join. I can say letters dot join, and then I can pass it what I split on, and then it will join it using the same thing. So I get back my original word there. So you can think of join as the opposite of split, right? Split takes it and puts it into an array, and join puts it back together, right? But I can join using different things. I could join, say, using exclamation point, and it basically puts exclamation points between every letter. You know, I could join with a space, and now they're spaced out, right? Because it's the opposite of split. With split, we take the character we want to break it up into pieces with, and in that process, you lose that character. And the join does the opposite. It puts that character back in and puts it into one string, one final string. Yeah? So now, if I have my letters, if I want them to be that anagram signature we talked about, we need it sorted, as you said. So you can just say letters dot sort. And now we have our sorted letters. And we can look at it. Here's our sorted letters, E-E-H-R-T. And if we join it back with the empty string, we get our signature, anagram signature. Yeah? So, what we can now do is say we can say that something is an anagram if the anagram signature of word 1 is equal to the anagram signature of word 2. Right? All right, let's run it now. Node anagram. And so now it's printing out true for this line down here is anagram. Oh, wait, no, sorry, it's printing out this one still. Let's comment that out and do our own thing. Console.log. And run it. Cool. See that? So it's returning true. I'm pretty sure that that's this one. We can double check it by removing a letter, and we can run it again. False.
Why does your equal sign have 3 of them?
So the reason for that is, if you recall, 2 equals in JavaScript just makes sure that the values of things are equal, but not that the types are equal. So like, for example, we can check, is 1 equal to 1? Here we're saying, is the number 1 equal to the string 1? 2 equals will say true, but 3 equals will say false. The number 1 is not equal to the string 1. So 3 equals is sort of a strict equality. It makes sure that not only are the values equal, but the types are equal as well.
I see.
Mm.
What about 1 equal sign?
One,
Does that do it?
it does. 1 equal sign is for assignment. So when you say 1 equals, it makes the left-hand side equal the right side.
Oh, it makes the, it's
Like
a
this.
command.
Yes, it's like a command, like we did on line 28 here, or line 29 here. You're assigning this value to this variable.
Oh, yes.
Mm-hmm. Yes. Okay. Excellent. Excellent. So the homework problem for next week is going to be still anagram related. I'm glad you figured some stuff out. As you can see, I prefer my code. It's much simpler. You can definitely use this recipe, right? To do your thing. The problem that I want to give you is very interesting, and it is to find the longest pair of words. Find the 2 words in the dictionary that are the longest anagrams. That is the longest anagram.
2 words? Oh, right.
Or it could be 3. It's possible that the longest anagram in the dictionary anagrams with more than 2 words, right? So this is going to be very hard. But
Okay.
I think it's very interesting. Like, now that you have sort of thought through what we're doing, the next step is to, try, do even more interesting things. So anyway, that's a problem. I'm only going to give you that one problem for next time.
Okay.
Let's talk about the lesson for today. So the lesson for today is we're going to do classes and, let me keep this over here and then keep your faces on the screen and code along with you. Okay. So you've already sort of seen, so I want to talk a little bit about classes, but I don't want to talk too much about it, okay? Because we don't need to do too much classes. You just need to understand what they are, and then you'll start seeing them in places. So let me give you an example of what I'm talking about. So this word is essentially an object, right? That's the word we use for it, right? This is called an object. We've seen objects already many times. Arrays are objects. Strings are objects. In JavaScript, I think most things are actually objects. And what an object is something that that sort of contains some data and provides things that let you operate on it, methods. It looks very much like functions, but they're just slightly different. So this word had this method called split, right? And when you split it, you get an array, and that array had a method called sort. And so because we keep returning objects, we can chain these operations on the object, which returns other objects. And each object that it returns we can chain a method that it contains, right? Okay, let's not talk too much. Let's just do it, okay? So what I want to do is make a fraction with you, a cool tool. So let's new file, and we're going to call it fraction.js. And inside fraction, I'm going to show you all the components that we have that is part of a class, right? So you start by saying class, and the class name is going to be fraction, right? And now objects have a thing called a constructor. The constructor is what allows you to make instances of them, okay? So here's our constructor. So what does a fraction have? What are the pieces of data we need in order to represent a fraction?
A divider? I don't know.
Yes, a divider. Mm-hmm.
And two numbers, I guess. One number.
The top, yeah, that's right.
A denominator and what's it? I forgot what they're called.
Yeah, you got it. That's right. You need a numerator and a denominator, a top part and a bottom part.
Yeah, numerator is the one.
Yeah. So the divider is an implicit property of a fraction. It doesn't change. So you don't need to keep that, right? The fact that there's a bunch of properties associated with fractions that because this object represents fractions, you only need to keep track of the things that are different between different fractions, right?
Wait, this is so weird. Today I brought fractions up and a story about you, Dun. I told Richard just a couple hours ago that I went to you for help with fractions in grade 4. And then you taught me a new way to multiply fractions. And then I was using that, and then in class the next day I told my teacher, and my teacher was like, oh my god, this is amazing. So he taught that way to the whole class. That's grade 4.
That can't possibly be true.
Yeah, Mr. Solage, he did it.
Okay.
Mr. Solage did that.
Yeah.
Okay.
I don't know who that is.
Yeah, I knew Mr. Solage in elementary school. He's this French guy. He looked like kind of Polish or something.
You had Mr. Solage?
Yeah. Because he was the guy that one of our students he attempted to throw a desk at one of our students.
What?
Because they absolutely pissed him off.
Okay, we need to talk about that later. Okay.
So fractions, yeah? So there's this keyword called this. This dot numer equals numer. And then I'm going to explain what all these things mean in a sec. This dot denom equals denom. Okay. So we have this word here, this, and then we do dot numer, and we do this dot denom, and then we set it equal to this, and it looks weird. Do you agree? Looks weird?
I don't know. It looks normal.
It looks no weirder than any other weird thing you see. That's fair. That's fair. But I don't want to.
Because the word this is in it. This dot numer.
Yeah.
It's kind of
So I don't want to spend too much time going into classes because I just need you to know that they exist. I don't need you to fully internalize object-oriented programming in one crash course lecture. But what I am trying to show you here is that we have these arguments numer and denom that get passed in, right? And all this is doing is assigning numer and denom to some internal variables. It's kind of like this dot numer allows us to keep track, allows the fraction to keep track of a piece of data, right? So it's kind of like saying my or self, right? Imagine fraction is a thing that has purpose, that has agency. Imagine it's a person, and you say, hey person, here is a numer and a denom, have it. So this is kind of like them saying, thank you for giving this to me. I will hold on to them. I'm going to hold on to this numer and I'm going to hold on to this denom. And that's what this is That's what this code is saying, okay? So this fraction now knows about numer and now knows about denom. Got it? All right. So yeah, that's how you make an object. So let's see how we this is the definition of the object. Think of it as like a blueprint, okay? The class is the blueprint of the object. We can now make multiple different versions of it. Let me show you. You can say let f1, this is fraction 1, equal a new fraction. And this is how you call it. So what fraction do you want this to be?
Like a half.
All right, there it is, a half. Okay? We can now console log f1. Let's see what it does. Head down here, node fraction, run the fraction. So now we have fraction whose numer is 1 and whose denom is 2. Got it?
Mm-hmm.
Cool. Let's make another fraction. Let f2 equal a new fraction. What do you want this fraction to have?
1/6.
You got
No,
it.
let's do a different top number. Let's do 2, and the bottom one is 7.
All right,
Make it-
2/7. Let's go. So now if I console log fraction f2 and run it, I can see that we now have two fractions. Fraction 1 is a half, fraction 2 is 2/7. Okay? Notice that this one object this one blueprint is being reused to hold different fractions. That's the key here, right? It's no different from the way that we have different strings, but now we can organize the data however we like. Does that make sense?
Mhm.
Okay.
Mhm.
Now, here is the bit that I want you to internalize. Let's make a function called reciprocal. Reciprocal. Who knows how to spell that?
You're right.
So there's reciprocal. And what reciprocal does is it swaps the numer and the denominator and inverts the fraction. Okay? So there's two ways that we can do this. I'm going to show you both ways, and you'll see what I'm talking about. So say this dot numer equals this dot denom. Now that's a slight problem because that means we've lost numer, so we need to hold on to the old numer. Let old numer let old numer equal this
That's what
dot
the
numer.
kids call it these days.
And then this dot denom now needs to equal to the old numer. So there's our reciprocal, right? So now check this out. We can now do this. This is what I want you to see. f2 dot reciprocal. Okay? And now if I console.log f2, what do you think is going to happen?
It will flip. 7 and 7 will be the numerator,
Yes.
and 2 will be the denominator.
Yep. So this is what f2 was, and now this is what f2 has become. It got flipped.
Ooh. Wow. So as soon as you're at the reciprocal, and then you just define those things as the other thing.
Yeah, I inverted it. Yeah. So that's one way to do a reciprocal. There's another way that we could have done this reciprocal, and it's actually my preference to do it this other way. And more programmers these days, I think, are moving to this way. And then we'll talk. I will just quickly talk about the differences, and then I want to show you how this is something you're already using when we use arrays and stuff like that. And then we'll be done with this topic, and then we can talk a little bit about regex, which is cool. So we could also instead of swapping the actual values of numer and denominator here, what we could have done is just said return new fraction, where we pass denom as the numerator and numer as the denominator. Oh yeah, I need this if I can't forget my this. Okay. Now, if I run this code, look what happens. The fraction no longer flips, right?
It's back to normal.
Yeah. And the reason why the fraction doesn't flip is because instead of modifying itself, reciprocal is returning a new fraction. So I have to say let f3 equal f2's reciprocal, and then log f3 instead. And now if we run it...
And now I'll print that one.
Yes. So you see the difference?
Yes. So reciprocal here, return new fraction, this denom. So then you made this denom come first, and this number come afterwards, just based on how you listed them?
Correct, yes, because the constructor takes numer first and denominator, so by passing the denominator then the numerator, that's a way to flip it, yeah?
Interesting.
But the key, what I'm trying to show you here, is that in one example, we mutated the fraction f2. In the second example, we returned a new object, right? Because
this is a new entity. It's not like you're taking the old thing and changing it.
Correct. And both are valid ways to work with the data. In some cases, you may want this one instance to mutate itself, and this is how you would write code that does that. And in other cases, you want to return a new object while leaving the current object the same. Got it? All right.
Yeah, right.
Nice.
Like
okay.
if you use the data from the beginning in a certain way and you don't want to mess with that. Okay.
There are various reasons why you may want to do it one way or another, which we don't need to go into. It's not important, but one thing to notice is that in many kinds of operations, returning a new object makes more sense. Like, for example, when you split a string and then it turned into an array, you have no choice there, right? Because you're returning a different object altogether. It's totally different it went from a string to an array. So you couldn't mutate anything to begin with, right? But sort, on the other hand, sort could have sorted like the value as it was, or it could return a sorted list while leaving the original alone, right? So when you do something and you modify something the way this reciprocal was done, we often say modify in place, right? So you'll often, like when you're looking through documentation for stuff, you might see sort will sort in place. It means that it sorts the value and modifies itself in place, right? That's a very common way to say it. You with me?
I think so.
Okay.
What was the sort thing again?
What was the sort thing again? So we were using it, yeah? So
Yeah.
take a look at this. We did word.split, and then we did .sort, and then we did .join, right?
yes.
On the anagram. So this word.split returned a new array. It's like a method that exists on strings, right? The same way that we have reciprocal on our fraction, right? Split is a method on strings. And then it returns an array. And then that array has a sort method, which is a method on arrays, again, defined just the same way that we did reciprocal. And then that array has
Another method.
yes, called join. And this is why we're able to chain things together like this. Okay?
You see, because they're all the same method.
Because there's a bunch of there's a split method on strings, there's a sort method on arrays, and there's a join method on arrays. Yeah. So we can have multiple methods. We can have multiply. And if you're multiplying, that means you need another fraction to multiply it with. So you should take an object like the other fraction. And then you can do this in two ways. You can multiply in place, the same way like we did our reciprocal the first time. Or we could return a new fraction that is the first one times the second one, or that is to say, the current one times the one that got passed in. So here's how you would do that. You would say return new fraction. And you want to take a stab at this?
Me?
No, I you know what? I'm going to show you. I don't think so.
Not ready for this.
So here's the key, right? Yourself is called this. So if we're multiplying, back to grade school mathematics, multiplying a fraction is the numerator of the first fraction times the numerator of the second fraction. And the denominator is the denominator of the first fraction times the denominator of the second fraction.
Mm-hmm.
So the first fraction is called, or not the first fraction, the fraction that multiplies being called on is called this, right? That's what this is. So we can say this dot numer, and we need to multiply it by others numer. Others numer. Okay? And now for the denominator, tell me what to type.
Oh, this dot denom times other dot denom.
You got it. That's right. So now we can multiply things together. Let's say let f4 be. How do you think we'll make? Let's multiply f1 and f2 together. How do you think we instruct the computer to do that here?
We're doing F1 and F2?
Mm-hmm.
Oh, F1
Mm-hmm.
dot
Mm-hmm.
multiply?
Yes.
One moment. F2 has to come into here.
Mm-hmm.
Would you do another dot?
Mm-mm. It's like a method. And so the method.
Oh. Open bracket?
Mm-hmm.
F2.
Uh-huh. You got it. Good job.
I did it.
Nice.
That's nice.
All right, let's try it out. So there it is. Fraction 1 times fraction 2 is 2 over 14. Which is 1 over 7. So we should reduce the fraction, but that's okay. If you wanted to, actually reduce is a good example of a method that's worth having that mutates, right? Because you want the fraction to reduce itself to its lowest possible value, right?
Mm-hmm.
But I don't want to get into Euclid's algorithm right now, so
That's just fractions. That's just simplification.
Mm-hmm.
We don't need that.
So that's classes. You don't need to use them for most things. Like the vast majority of time, we're able to write functions to do all the things we care about. And every now and then it will be useful to make a class. And let me give you an example of where that will happen so that we can think forwards to that. Classes are great when it's important for us to keep track, when it's important to keep pieces of data together. And in my experience, the best times to use a class are when you're building games. Because you can use a class to represent an object in the game, and the object can hold on to things that are specific to itself. Things like if you have a card, what is the value of the card? Where is it currently on the screen? Is it visible to the user? How fast is it moving? If like it's an object that is animated, how fast is it moving on the table, right? All of these things can be kept track of inside of one object, and then that way it's very easy to know what's going on. And just so you know, we've been using classes, but I haven't been telling you. Secret classes. When we go back to Python, you'll see them as well. They're there too. It's useful for modeling our data, and that's why we would want to use them. Okay, done. We're done. That's classes, and I was going to teach you some array processing, but you did that yourself. I don't think I need to teach it to you.
That's so funny.
Yay, we did it.
When
Hey.
you were doing this stuff, you did sentence dot split and then you did dot filter. Filter is a method on arrays that takes a function and filters out things from the array. It's a method on arrays. And you did a bunch of things on that one line that is very advanced. You passed an anonymous function. Remember we were talking about named functions and anonymous functions not too long ago? Let me pull it up on the JS crash course. Once upon a time, we were looking at functions. Here they are. And we had named functions and we had arrow functions. And we were asking, why do you want an arrow function? And the answer is it's useful for stuff like this, where you did filter, and then you said filter for words, where word dot length is not equal to 0, right? That's what this was the code that you used to have. I think it's useful to go back to it so that you can see what it's doing. So this bit of code filters out words whose length is 0, right? So you have an array here, right? By splitting the sentence by space, you have an array.
Right.
And then you say filter out all instances where word.length is equal to 0. And this here is an anonymous function, right? Or arrow function, as I called it before. Anonymous, arrow function, same thing. And you could have done it this way. You could have said function is length 0, right? And then
it
takes a word and it returns or maybe is not length 0, right? And now you can just say filter and you pass is not length 0. And this does the same thing. But as you can see, by doing this arrow function here, we, in some sense, this is simpler, right? I mean, when you learn to read code very quickly, I think this is in fact simpler. You don't want to have too many. Like, it's useful to make separate functions when those functions are complex, but when they're simple enough, it's useful to see them like this.
Nice.
Yeah, nice.
Yeah, the only way, like the only reason why we would do it in a helper function is if we need to pull it. I mean, but I guess in that case we would just arrow function other situations.
Yeah, definitely. So let me show you another example of that. So there is another method that you have is called map. And what map does is it applies a function to every element in the array. So let's take a look at this translate. We can go like this. We can say function to pig Latin. This is basically translate to. Let's call it that. Translate to, right? Sentence. And what we'll do is the same thing that you did, right? So we have sentence split and filter out these 0 length words. And what we'll do is we'll say map. I think it's map. And what map will do is we pass it another function. And what this function will do is it will call another function and transform it on the fly. Okay? So in our case, we want to call your one word. So we'll map one word. And then we have an array now that has every pig Latin word in it, right? So that array can just be joined with a space. And so we're done. We can just say return sentence split.
Oh my god.
So we can just say sentence, split the space, remove words that are length 0, map the one word to pig Latin, and then join it back into spaces. And so now we can just say console.log translate to of I love the sunshine. And let's run it. There it is, the second one.
Wow. That's fun.
Yeah. So a lot of code can actually be written this way, where we're essentially using like just some basic array processing techniques. So you take something, turn it into an array, filter some stuff, maybe sort some stuff, apply a function via map, and then join it back all together. You know? Yeah, goals achieved, you know? Yeah, and you could and because of the way that chaining works, you could even just add that here, get rid of this altogether. So sentence, two lowercase, split, filter, map, join. And I would change the name of one word. Instead of one word, I would call this to pig Latin, or pig Latinize. And then instead of string here, I would use the word word, because we know that it operates only on one word at a time. So I would replace all these strs with word. Right? And now this function is documenting itself. This function converts a word into pig Latin. Right? All right. And then down here, we have map pig Latinize. And now this whole thing is very readable. Maybe. To me, it's very readable. Translate sentence by first taking the sentence, making it lowercase, split it, filter out the empty words, pig Latinize each word, then join every word back into a sentence, separating each word with a space. All right.
Nice. Wow.
Yeah. Okay. So we're over time. But let's talk a little bit about regex. Or maybe no. Let's save regex for the next one. There's a lot there. I think it's useful to talk about it next time. But what I might do is have you investigate regex on your own, because there's a lot here. So we did some problems together where we converted the left-hand word. Okay? We tried to find the longest left-hand word, right?
Yeah.
What I want is you can do this left-hand word thing using regex, and it becomes a one-liner if you do.
Whoa, and it's just dashes and so forth.
And it's just, yeah. So let me show you your code. You had this anagram. You did this bit here. So you can do something.match to see if it matches a pattern. And the pattern that we care about is whether or not you can type something with your left hand. So it's possible to represent strings as a pattern, and that pattern can be left-hand letters, right? This pattern that you have here is the pattern not matching a word character. Okay? That's what this pattern means. But there's many, many different kinds of patterns. Let's take a look at some. And then we can... basically, I think it'll be useful for us to... Yeah, if you have 10 more minutes, let's just go through some basics of patterns, and then we can try to find some stuff. So, regex cheat sheet. Let's go. Ooh, this looks interesting. I've never been to this page before. Is this a cheat sheet? It is kind of a cheat sheet. I don't know if it's a useful cheat sheet. But, okay. Okay. Let's create a new file here, and let's write some things down. Let's write down 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. What is this?
All these numbers.
Yes, that's true. But what pattern? What pattern does it look like to you?
Oh, phone number?
Yeah, it looks like a phone number. So we could represent phone numbers. You might say that a phone number is 3 digits followed by a dash, followed by 3 digits, followed by a dash, followed by 3 digits. Right?
4 digits. Yeah.
Correct, 4 digits. So let's say that we wanted to find all phone numbers in a piece of text. So like, hello, my phone number is this. Please give me a call. Let's say there's like this huge document and we need to find this phone number in there, right? We don't know what the phone number actually is. So how do we find it? And the answer is with regex. Now, you could write this as a for loop. You could write a for loop, and then when you see a number, count, okay, I saw a number, then check the next letter. Oh, I saw another number, then count the next letter. Oh, yeah, that's another number, then check the next one. Oh, that's a dash. Or you can write a pattern that matches it, okay? So here is a pattern. So you see me in VS Code here. There's a few buttons here. If you mouse over them, you'll see, okay, this one here is match case, and then this one here is use regular expressions. So regex, by the way, is short for regular expressions. So yeah. So we just turned them both on. Now, here's how you write a digit, \d. And look what happened. It highlighted every digit in this file. See? You see all the digits are now highlighted. Now, I want to highlight specifically 3 digits. So I could write this like this, \d, \d, dash, \d, 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 dash, \d, 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 \d. And now it's found a phone number. Also, if I were to go down here and type another phone number, it matches now. But it only matches as soon as I have the last digit added. Oops, digit added. And if it's not a number, it doesn't match, right? So here is a pattern that matches this, right? Now, there's a shorthand for things that happen in a row. You can do this. So I can just say how many digits, specifically like this. So now now it's saying 3 digits followed by a dash, followed by 3 digits, followed by a dash, followed by 4 digits. And there is my phone number pattern. Now, it's going to take a very, very, very long time to learn regex, but the neat thing about JavaScript and most programming languages is that you can first come into VS Code here, test out your regular expression against some text that you type out, and then just copy paste your regular expression to be used in your JavaScript. Let me show you another thing. Let's say that I had, let's say that I have a left-hand word, adder, okay? And let's say I have also a non-left-hand word, brother. So if I want to match a left-hand word, what I could do is I can say all the left-hand letters are these ones. Is B a left-hand word? It is, yeah. Okay, B.
I had the same question.
So this now matches those letters. And I can check to see plus, for example, will mean one or more. So what has it matched here? It's matching E, s, e's, all of, like, it's highlighting all the individual letters and then, giving you them as they match, yeah?
Yeah, that's so cool.
So let's try this out in JavaScript. Let's go down to new file, regex.js. So I can make a pattern.
Anwar is here.
Oh, hey, Anwar.
He found a website useful for using regex.
Yeah, drop that in the chat. We'll give it a try. So so here's a phone number pattern. And in JavaScript, we represent regexes with 2 slashes. And so a phone number pattern is what we had before. Oops, I got rid of it. So we'll just type it again. \d 3 dash \d 3 dash \d 4. So there's our pattern. And now we can do this. We can say let the number, let's try this, 1 2 3 4 5 6 7 8 9 0, or that's fine. Let's call this test number. Okay, we can now do test number dot match, and then we can pass wait, is it hold on, is it match phone number pattern? Let's start Quokka up. Console.log.
It's useful, see?
All right. So there it is. It matched it at position 0. Let's try out the regex thing. That
Anwar said he pasted it in Discord because YouTube doesn't allow links.
Oh yeah. So here is a tool. Let's try out our expression. \d 3 dash \d 3 dash \d 4, and then tests text. Okay, so now we should be able to come in here. 1 2 3 4 3 4 whatever, just some numbers there, and it highlights once the match occurs, and it tells you where the match occurred. Nice. So this is the idea. Cool. So in JavaScript, you can run these matches like this as well. Is match what I want? So there is a way to anchor your matches to the entire expression by putting this little caret guy and a $sign.
Yes. He called it a carrot.
The caret. Yes. I don't know. Is it called something else? So look at this. If I put a space here, this console log returns null. It no longer matches. Right? So only when the entire thing matches the expression does this work. Okay. So that's some regex. And we'll go into some more of it next time. For now, I just wanted you to notice how regexes show up. And so the important bit is that they're between these slashes, right?
Yeah.
On line 1, they're between these slashes. And you've used them already, right? In line 22 of your anagram. You used it to delete things that match the pattern. In this case here, caret \w means, in this case, caret is slightly different. In my previous one, it was an anchor to the beginning of the expression. But when it appears in square brackets, it means not. It means not \w. And \w, so \d was digit. So \w is word characters. And that's why this deletes exclamation points, because exclamation points are not word characters. And then you're telling JavaScript to replace in the string all things that are not word characters with the empty string. Okay?
That's so genius.
Yeah, it's pretty genius. I agree. Okay. So the second bit of homework for you is, and it's totally okay if you don't figure this one out. Regex is complicated. So you saw me kind of come up with the left-hand pattern, right? Try to see if you can come up with a regex pattern that is the left-hand pattern, and update our left-hand code such that this is left-hand word is a one-liner regex expression. You should be able to replace lines 53 through 23. You should be able to replace all of this code as one regex expression.
You mean 23 to 53?
Yes.
Okay. Ooh. We can do it. We can do this.
Yes.
Okay.
It is done. We'll try.
Yeah, we'll try.
Yeah.
We'll message you this time.
Okay. Sounds good. And I'm going to have another regex problem for you next time. We'll do some more regex together. The thing about regex is that it's totally okay if you don't remember the majority of what you end up learning. That happens.
Right.
Like I've been exposed to regex for a long, long time, and I still need my regex cheat sheet.
Yeah. A lot of it's like memorizing.
Oh yeah.
Or like with practice too, like.
I think this website, though, that Anwar gave us looks really good because you can type an expression up here, and I'm noticing that it's showing you helpers at the bottom here. It's kind of explaining it to you. It's kind of saying, look, \d matches any digit, match 3 of the preceding. Okay, you know what that means, right? I mean, let's grab your anagram regex and see what happens when we put it in the explainer.
Oh, yeah.
Yeah, here we go. Negated set. Match any character that is not in the set. \w word. Matches any word character. Alphanumeric and underscore. Ha. This is really great. Thanks a lot, Anwar.
Yeah, it's amazing.
So you could test out your stuff with this. Yeah, so notice what it's matching. It's matching everything that's not a number or a letter. So like all the spaces, the ampersand, all this stuff. And so when you say replace, it essentially grabs all of these things that are not part of the word and gone. All right. Okay, so that was a very fun session.
Yeah.
This is our last one, actually. This is the last one for our crash course. From here on...
Oh, what about our regex stuff next week?
Oh, yeah. Well, I mean, I've now taught you everything I wanted to teach you, is what I meant. We'll go over some more regexes. But this is like after the next one, we essentially have gone over the basics of programming as far as I think they matter. There's some more things that we're not going to cover. Things like recursion. Well, maybe you know what? We could give it a try. It's just that stuff is really computer science-y, and we hardly ever need them in real life when we're programming because... But if you ever wanted to like solve a maze or solve Boggle or write things that do that, you would need some of these tools. So, yeah.
So it's useful if you want to create a game or a randomization type thing.
So, yeah. Well, I don't... There is certain kinds of problems where those tools will help us. But for now, like, I think if we spend our time just getting good at this stuff, it's enough for the majority of the app building we're going to do. And it's time to get back to some app building now that you've seen the basics, you know?
Yeah.
So what do you think?
Can't wait to come into the project with a new perspective.
I think that it will help, yes.
Yeah. Thanks, Don.
Yeah, no problem.
This was a great lesson.
Yeah, thanks. It really helps just put things, define things so that when we look at them again in the context of the API or the app,
it'll be familiar and we'll actually know what's happening. You won't have to explain every little thing. And yeah.
Okay. If you want, I did a couple streams this weekend. They are beginner friendly. They are in Python. You have enough knowledge to be able to understand the topics. The very first one is especially fun. You can probably skip the other two unless you're very interested. The first one that I did on Saturday, though, is very cool. So maybe if you want, take a watch.
Take a gander?
Yeah.
Do it.
Okay, so let's make that the homework then. So the homework is where were we?
Saturday stream. Homework is to find 2 words in the dictionary that are the longest anagrams.
Mm-hmm.
You also said investigate regex on your own, and also a regex pattern that's left-hand.
Yes, that replaces our left-hand word. Mm-hmm.
Left-hand code in a one-liner.
Mm-hmm.
And then the Python video.
Okay, that sounds good. Once you've done that, we will use you'll probably learn a bit of regex, and then we'll come back and we'll fiddle with regex to do a few other things, like maybe list all words that satisfy a given constraint, which is useful for things like crosswords. Like, let's say you want a word that matches a very specific pattern. It's a specific length, and you know specific letters in it. You can do that with for loops, or you can do that with regex. So we'll do that next time. I think every anagram in the dictionary is going to be very, very challenging. You'll need to apply some of your knowledge. But remember, start with your recipe. Think through how you'll go about finding the anagrams, like all the anagrams, right? And how you're going to keep track of them. How you're going to keep track of the longest one, right? Because this is not the same thing as what you've done before when you searched for the longest thing, right?
Mm-hmm.
But that same brain that you folks have that came up with the idea of sorting the letters and then comparing them, that's the brain you need to solve this problem.
Use that brain of yours. Use that noggin.
No. Both of you have this brain. I'm just pointing out that this is not syntax. This is problem solving, right? So it's all about figuring out how you'll do it. The syntax is the easy part. Yeah? Okay, good luck.
Yes. Thank you.
All right.
I don't think it's easy because I also think that it requires some thought. Okay?
Okay, we'll really think about this one.
All right, sounds good. All right. So, good stream. Thanks for joining, Anwar. I really appreciate it.
Thanks for joining, Anwar. And
All
for your
right.
help.
And, yeah. Bye, internets.
Peace out.